Hello everybody, myself Venkatesh, and here our team Abhilash PG, Anjan SR, and Basaraj. And here we taken the instance-based learning of a KNN Navy-based design decision tree of predicting a spending category. And here we are going to explain about a company wants to classify a new customers into a different spending categories as like low, medium, high based on their past shopping behavior. You are required to implement different classification algorithms, K nearest, KNN decision tree, and Navy bias to predict the spending category of a new customer. And here is the accuracy, precision, recall, and F1 score. Line number 1 to 4, import the basic libraries used for data manipulation and visualization. Pandas imported as a PD, a uh, powerful library work from the often users working in the data tabular from data farms. Here in NumPy is imported as a NP, a fundamental package of a numerical computing in Python used for handling arrays and mathematical operations. Here, a Metapilot lab is imported as a PLT app, floating library to create a static, animated, and interactive visualization. Seaborn has imported as a SNS, a Python visualization library based on the Matpilot that provided a high-level interface for drawing and interactive or informative statical graphics. In line number 5 to 9, imported a specific models for Scholar. Yes, Scholar, a popular machine learning library, test, train test split, and standard scalar, and label encoder. And here is a k-neighbor classifier and decision tree classifier, and Gaussian NB. And here we are predicting the accuracy score, precision score, and recall score, and F1 score. Here the F1 score means we can all calculate the precision score and a recall score, and we can get the evaluation matrices used to assess the performance of a classification models. And here in line number 11, we define the path of a data set assumed to a file of a mall customers in the we named a mall customers in the file name, which should be located in the working directory. In line number 12 to 16, try to read all the file path to load the data set into a data farm. If the file is found, it loads the data into the variable. If the file does not found, we will raise the message to the printer saying the dataset could not be found. The program will be in the next exit using the exit column. Here in line number 17, the customer ID, we rename the columns of a data form to more reliable and consist names. Here customer ID is a unique identifier for each customer. Gender is the gender is the gender of the customer, and age is the age of the customer, and annual income the customer's annual income, and the spending score, score represents the customer's behavior, spending behavior. High score or more, higher or a higher spending. In line number 18, instate label encoder object which will be used for encoder categorical variables into a gender into a numerical labels. In line number 19, we apply the all label encoder to gender column of the data form. If a gender has a category like male, female, this will count those categories into a numerical values. For example, 0 has a male, and 1 has for a female. This is needed because the machine learning algorithms work better with the numerical data. And next, my friend Abhilash is going to explain the.
Thank you, Venkatesh, for explanation. I will continue from line number 28. It is line number 28. It is used to divide the spending code in the column into three categories: low, medium, high. Low from 0 to 40, medium to 40 to 70, high 70 to 100. This means the parameter specifies the numerical range 0, 40, 70, and 100. It labels the parameter assigns the categories names low, medium, and high. Includes the lowest just to ensure that the lowest value is 0 and includes the lowest categories. The result of the new column spending code category which contains low, medium, high for each row. Line number Line number 32. This removes the rows where ending core categories is null. The row will be have null if its spending score was missing none before categorization. In place true means the changes are applied directly to the definite instead of the creating a new data frame. Line number 35. Create a new data frame X that contains only selected features: gender, age, annual income, spending. Copy ensure the text is separated a copy of the data, so modifying X won't affect it. Line number 36. This converts the age, annual income, and spending score into a floating point number. This ensures that numerically operated like scaling work correctly. For example, if age was stored as in the integer 25 and it converted to the float 25.0, line number 37 is creates a copy of the spending category column. This will be target value output for the training machine learning model. Line number 30 40 line number 40 Line number 40, standard scale is the object from the scalar. This categorizes the numerical data source that means is 0 and the standard division is 1. It helps the machine learning model work better. Line number 41 calculates the means in the standard deviation of each numerical column and scale them. This result in the scalar in the numpy array where age, annual income, and spending score are now standardized. For example, age is 25, 40, 60 is converted into 1.2, 0.0, 1.2 after scaling. Line number 42. Assigning the scale value back to the x, replacing the original value. The age, annual income, spending score, and selecting only this column. Now all numerical feature preparation. Next will be code continued by Anjan.
Data splitting splits the data set into training and testing sets. X and Y are the features metrics and target labels. Test size is 0.2, means 20% of the data is allocated for testing and 80% for training. Random state is equal to 42. Ensure the split is responsible. Then the dynamically selecting K for KNN. K is equal to max of 1 comma min comma fine len x dash train minus 1. This purpose is dynamically determines an appropriate k value for the k nearest neighbors algorithm. KNN algorithm. Explanation. Let x train ensures k does not exceed the number of training samples. Min 5 length x train limits k to a maximum of 5. Ensures k is at least 1. The initialization of machine learning models. KNN is equal to k neighbors classifiers. N of neighbors is equal to k. Then decision tree classifier random state is 42. This purpose is to create 3 different machine learning models. The models are k neighbors, a k nearest neighbor clarifier with k neighbors. Then decision tree, a decision tree clarifier with a fixed random state for responsibility. A navy base that classify using Gaussian distribution. Then kn dot fit of x train and y train. Then dt of fit of x train and y train. Then nb fit for x train and y train. This purpose is train each model using the training data of x train and y train. The explanation is to fit x and y train that model on the provided data set. Each model learns from the data to make prediction on new input. The summary of our presentation is the data set is split into training and testing sets. The valid KI value is dynamically selected for KNN. The models are trained under training data. Then my friend Vasu will continue. Thank you.
Kn dot predict generate the prediction for the k nearest neighbor model. Dt dot predict generate the prediction for the decision tree model. Nb dot predict generate the prediction for Neighbours model. These lines are used to generate prediction on the test set for each each of the three classifiers. This function definition for evaluating models performance, it takes three arguments: name, why true, why pred. Name, the name of the model being evaluated. Example, decision tree. Why true, the true labels for the test set. And why prediction, the predicted labels from the model. Next, evaluation models. These lines are used to evaluate performance of each model using evaluation models. Evaluate model evaluates the KNN model. Evaluate model evaluates the decision tree model, and evaluate model evaluates the Neighbours models. Each evaluation function call adds a model's performance metrics, accuracy, precision, recall, and F1 score to the result list. These line these line identifies the best performing model based on the accuracy, finds the index of the row with the highest accuracy in the results data frame, retrieves the model name at the row with the highest accuracy. The result is stored in the variable best model, which will hold name of the model with the highest accuracy, and prints the name of the best performing model based on the highest accuracy as determined in the previous step. This block of code generates a bar plot visually comparing the accuracy of the model. Creates a uses cborn bar plot function to create a bar plot. It plots the model column on the x-axis and the accuracy column and the y-axis. Each model is color coded using the palette blues. The hue model ensure the bars are colored according to the model name. This visualization helps for the quickly compare the accuracy for the each model in the clear and easy to understand manner. Next code output will show by the Venkatesh.
I am going to run the overall output of our code, and Abhi, you can going to run the code. Here is the overall output of our code, and here is the KNN model performance, precision, recall, and F1 score supports. And here high roll, high and low accuracy, and weighted average, and decision tree modeling performance is a prediction, also precision, recall, and F1 score supports. And accuracy here is all 3 3 we get, and here is a 2 1, and here is a Navy bias model performance, and here is the output of 2 1 and 3 3 3. And here is the best performance model decision tree based on the overall scores. And here currently we are not visibling of our graph, and paste on the report. So thank you all.